always, I'm going to do my best to chunk up our videos. So in this one, since we're going to do a review of algebra to begin, I'm going to do the first 3 sections as one, and everything that's grade isn't in these notes. And then the next 2 sections, still under review of algebra, and it says part 2 of 3. And the numbering for the examples continues. And then one more. Oh no, this one, I skipped it. Here we go. And then we've got 3 of 3, and you can see that the last 3 sections are colored and the others are grayed out. But all of the examples are numbered consecutively. And then we've got another section, and I don't know how much we'll get through. We have another section on which is just basically beginning trigonometry, and the numbering starts over. This isn't part of that other section, so I'm not going to continue the numbering for the example. And here, this does actually mesh with one of the sections in our book. So I'll always give you that information. Okie doke. Any questions before I plow forward?
We can find this digitally in the modules. Is that correct?
Yes. That's a great point. So let me actually change the share. I'm going to share my screen. Can you see yourself?
Yes, ma'am.
And teaching, here we go. And I need to make that go away and this go away. So here we go. Let's so if we go to our class, I put a link on the front page now that says class notes. You can click that. And then this is where I'll be putting in videos, like there'll be a video that will go with functions and a video that will go with critical points and composition and inverses and trig. And then there'll be more. And I just left these headers up so that I don't have to do as much work. And then I'm leaving some of the information that I compiled in earlier classes. And I'm leaving this textbook. It's a free text, and it's a very handy text. So does that help everybody know where to go for the notes?
Yes, ma'am.
Yes, ma'am.
Swell. All right. So one of the reasons why I make these notes and print out everything is that we've got huge numbers of words to define, a huge number. What I would like you to do is get a notebook or binder or something and start in one section, just start having a list of words. So that later you can go, whoa, I don't remember what that means. And you just know where to look. So we're going to start with a relation. A relation is any correspondence or mapping between two sets that are neither one empty. So like, for instance, we could have a dog could go to 1 and frog could also go to 1. And if we wanted to write the elements of this mapping, we could say there's dog, that's an input, and the output is 1. Frog, that's an input, and the output is 1. So there are 2 elements, 2 ordered pairs. These are called ordered pairs because it matters which position the thing is in. Here, the first element is a pet, and the second is a number. So we would say that the element 1, dog is not part of this because there's not a pet called 1 and there's not a number called dog. Functions are special relations. Functions have every single input has only one output. And let's look at this little one that we did. How many outputs does dog have?
One.
Exactly. And what about frog?
Also 1.
Good. So this little baby drawing is a function. But let's look at something equally simple that is not a function. Let's say we have dog and frog again. And the numbers 1 and 2. And this time, dog is going to go to both, and frog is still just going to go to 1. So we can list the elements. We would say that we've got dog, 1, dog input, 2 output, and frog is the input, and 1 is the output. So this is fine. And you can see that there are all sorts of examples of functions and relations that are not mathematical. But is this relation a function? And why not?
No, because if we take dog as the X value, it would, if we just put in the X value dog, we could get 2 answers.
That's right. And basically what you want in a function, thanks, Evelyn. Thanks, Ben. Basically what we want in a function is a rule that it's a good rule. In other words, every question has a definite answer. We're not getting many answers for a question. And there's a way that we can look at images. So let's see. Here's dog and frog. And we've got the numbers 1 and 2. And I can see that the 2 elements that are associated with dog 1 and dog 2 are vertically aligned. And we also have frog 1. But do you see that a vertical line would cross 2 places? And that's what makes this not a function. So this fails. The vertical line test. And you can see that it makes sense that a vertical line would be a good judge for a function because one input having 2 outputs means that a vertical line would cut it twice, at least twice. And now we can look at some functions, just some sketches. Is this sketch a function? Yes, why, Evelyn?
Because there's only one output to one input, and it passes the vertical line test.
That's right. If you trace a vertical line all the way across, it only ever crosses once. Very good. So what about this sketch?
That wouldn't be a function.
And why not?
Because you can draw a vertical line, I don't know, somewhere near the end, yeah, and it would hit it multiple times.
Yeah, so anytime the graph of something folds in on itself, or gosh, especially if you have something like this. So that after this vertex kind of over here, any vertical line is going to cut twice. So this is definitely not a function. This is not a function. So that what we are going to do is connect loads of things. And this is good training because in calculus, which a lot of you will take next, you're going to do the same thing, but bigger. You're going to connect all the stuff, and it's wonderful. So what we want to do is connect as many ideas together as possible. So we've got a function that means one input has one output, or one argument. Sometimes the input is called an argument, has one value. And that the graph or the image of the relation has to be such that any vertical line will never cross it more than once in order for it to be a function. So say we've got an equation and we want to see if that equation describes a function or just a relation. What we're going to do first is solve for y in terms of x, and then we're going to see how many y's will we get for each x. And you'll see in a moment why we ever get more than one from an equation. We're going to remember something that you may not have remembered at all. If you take the square root of both sides of an equation, you must put a plus or minus sign in front of one of the sides. We're going to put that in the back of our brains, and let's do this. We've got 2y is equal to 4x minus 1, and we want to know is this a function? Why or why not? So what's a good first thing to do?
Separate y and x.
Okay, so how can we get y alone?
Divide by 2.
Good. So now we've got y equals, do I need 4/2 or can I write it simply, more simply?
That would just be 2
2
x.
x
Beautiful.
minus 1/2.
And 1/2. And I'll tell y'all 100 million times, but here's the first. Fractions rule. Decimals are sometimes necessary, but they don't rule ever. And mixed numerals. Ew. Ah. This means nothing. 1/1/2. It's not multiplied, it's not added, it's just confusing. Whereas this has lots of meaning. This has a numerator of 3 atop, a denominator of 2 at the bottom. And we know that this bar means division, so it's 3 divided by 2. And so if I need a number, I can put that in my calculator and get a number. So I'm going to harp on things like that a lot. Is there something that we can know about this kind of equation? Does this form a pattern?
It's a slope.
It's a linear equation, yes. Where the slope is which number? Is the slope the number next to x, or is the slope the number without an x?
The number next to x. So the slope would
Good.
be 2.
Yes. And since slope, let's write it this way. The slope is 2, but we think of slope as rise over run. So I'm going to write it as 2/1. And I don't have to do that, but it helps me remember what this number means. The minus 1/2, what is that? Does anybody remember?
It's
The
the
intercept.
y-intercept.
Good. So the y-intercept, this number is b, then the y-intercept is 0, b. So for us, we have 0, negative 1/2. And it's pretty easy to sketch this. Let's see. We're going to start with the y-intercept. We go to 0 and then what would that be? -1, -2. So negative 1/2 is here. And how do we interpret a slope of 2/1? Rise over run, 2/1, what does that mean?
That for every 1 we go right in the x value, we'll go 2 up in the y.
That's right. And I usually, since rise is on top, I usually do that one first. But exactly right. So here we've got 2/1. That means we're going to go up 2. And to the right 1. And so now we've got a nice, very, very simple graph of this. And the graph itself tells us what? Is this thing a function, or yes or no?
It is.
Yes.
And another way that we can know that it is, any x that we plug in here, multiplying it by 2 is not going to create 2 answers all of a sudden. Subtracting a half from it is not going to create 2 answers all of a sudden. So it's kind of easy to see 1x here is going to give us 1y. Oh, I meant to say, and I forgot, the notes will have a try this for every single example that we do. And we're going to experiment. I'm going to try, I'm going to pause the recording. So who's going to help me remember to unpause?
I will.
Okay, so I'm going to pause the recording so that y'all can have about 5 minutes to work on this. And if this goes well, then you don't have to turn it in. The other people do. If this doesn't go well, then we'll just skip these and you'll turn them in later. Okay, so here we go, pausing.
Oh, sorry. Yes.
That's okay. It's really hard to remember. That's why I want more than one person to pick on me about it. All right. So let's look at the relationship y squared is equal to 6x. Does this represent a function? Why or why not? Well, just like before, we're going to solve for y. And how do we undo squaring? What's the opposite of squaring?
Square root.
Or root.
That's right. So we've got y squared equals 6x. I want to take the square root of y squared so I get y, but that means I've got to take the square root of the other side. And anytime I take the square root of both sides of an equation, I have to put a plus or minus sign in front of one of the sides. Oh, here's just something fun. What exponent is square root?
2.
Squaring is 2. It's almost 2, but not quite 2. Square root.
Isn't it -2?
So if you had y to the -2, that would be 1 over y to the second. So negative exponents are fractions. And then a whole number exponents, those are powers. So how would we do a root?
Isn't it a fraction? Like a half?
That's right. Exactly right. If we have y squared and we're doing the square root, that's the same as y squared to the 1/2. And do you remember with powers of exponents, properties of exponents, you multiply if you have an exponent raised to an exponent. So what is 2 times 1/2?
1.
Good. Which is just y. So that's why square root is the opposite of squaring. So we get that y is equal to plus or minus the square root of 6x. Let's look at one particular input because it gives us a nice answer. Let's let x equals 6. And I'm going to write this instead of y. No, I'm not. So let's see. I have plus or minus the square root of 6. Oh, times 6. Huh, nice. Okay. And 6 times 6 is?
36.
36.
Yay. And why did we choose that one?
Because it's easy to square root.
That's right. Square root of 36 is?
6.
6.
I know we're surrounded by 6s. But that means that we've got 2 ordered pairs for the input 6. We have 6 comma positive 6 and 6 comma negative 6. And I printed out just a piece of this graph. This is in the solutions. But you can see that when x is 6, we're going to get 2 different y's. And in fact, this thing is like a parabola on its side. Definitely not a function, but we have several different connections. We've got the plus or minus that gives us a really strong idea that 1x gives us 2 y's. We have a parabola on its side, so we can see the vertical line test is going to fail. Just a lot of connection. And my brain was with me and then it left. It'll come back. Okay, so I want y'all to work on the relation x minus y squared equals 4. And I went ahead and showed that. Oh, I remember. So I'm going to write it down what I was going to say to you. And to play with this, I'm going to go away so that you'll definitely. Oh, I'm also going to pause the recording. So who's going to remind me to unpause?
Now pause.
Thanks. Excellent, excellent. Are you starting to feel a little bit, I don't know, a little bit more, a little solider? Good. That's the whole point, I think, of a live class, that we have this feedback sort of thing with each other. All right. Domain. You can have domains with relations and with functions, but most of the time we're going to think of a domain as something going with a function. And it's all the possible inputs. The range is all the resulting outputs. So let's see. Let's look at g of x is equal to 1/3 x minus 2. And the first thing we want to do is find the domain. We want to find what x is. Sometimes it's easier to think, what can we not plug in? So what number can we not multiply by 1/3?
Zero.
0 times 1/3 is just 0. That's good. You're thinking about it. That's good.
Mm,
3.
1/3 times 3 is
Just 1.
One.
1. So that's okay.
Oh, would it be negative numbers?
So
I don't think there is anything that we can't multiply it by.
Yeah, that's right. What were you saying, Lynette?
no, that just answered my question.
Okay. So yes, this is a linear function or a linear equation because we've got a number times x plus or minus another number. So it's in the form of y is equal to slope times x plus b, where 0b is the y-intercept. And we know that all lines are functions except one kind of line. What is the only kind of line that would fail the vertical line test?
A vertical line.
Yeah, that's right. So every other kind of line is, in fact, a function. So what is the domain of this?
All reals.
Yeah, we can write a double bar on an R means reals. We can write it in interval notation, negative infinity, comma, infinity. This is interval. Notation. And I do D for domain, sub G, G is the name of the function. And again, the R with the double bar is the grown-up symbol for the real numbers. Since this is not a vertical line and it's not a horizontal line, is there any limit to the outputs? If you could think of any number in the world, could I put that number instead of g of x and find an x that would get there?
Yeah.
Yes, that's right. So that means that the range of g is also all the reals. And you see, range is not double barred, only all the reals. Is the point 3, -1 on the graph? How can we know?
You can substitute 3
Yeah,
for
3
x and
for
then
x.
see if you get -1.
Yeah, let's see. Got g of 3, that's going to be 1/3 times 3 minus 2. 1/3 times 3?
1.
And 1 minus 2.
-1. -1.
Yay! So yes, it is. And we showed why. Because if we plugged 3 in for x, we do actually get -1 out. What is the value of g when x is 9?
Would
1.
be 1.
Yeah, we've got, let's see, g of 9 is 1/3 times 9 minus 2. 1/3 times 9.
3.
3.
And 3 minus 2 is exactly what y'all said. Okay, well, here's a little bit of a different thing. What x will give us g of x equals 2?
X equals 12.
Yeah, good. So if we had, and the way that we can do this is we've got g of x is equal to 1/3 x minus 2. And I'm going to replace the g of x with 2. And now I want to solve for x. So remind me how to do this.
You could multiply.
Add 2 on both sides. And
Yes,
then
that's a
multiply
good
3.
first step. So we get 4 is equal to 1/3 x And yes, what's the opposite of 1/3? What's the inverse of 1/3?
3/3.
That's right. So if we multiply one side by 3, we have to multiply the other side by 3. 3 is the same as 3/1. And why is it happy to multiply 1/3 by 3/1?
You're multiplying by the reciprocal.
That's right. And we get that x is 12. And to graph the function, we'll just remember that we know what the y-intercept is. What is the y-intercept?
0, -2.
Good. And what is the slope?
3/1.
Almost
Sorry, 1/3.
1/3. So a rise of 1, a run of 3. Rise of 1. We go up. We start here at -0, -2. We go up 1, 1, 2, 3 over. And we get something like that. Any questions about that stuff? Okay, I want y'all to do try this here, and I'm gonna mute myself again. And I'm gonna pause the recording. So please help me remember to unpause it.
Don't forget to
Thank you. At least for today, so far, I'm remembering because I'm asking y'all to remind me. So who knows? All right. So now we've got f of x is equal to the square root of 2 plus 3x, and we want to find the domain and range. And most of the time, especially when we're talking about graphing, we're talking about real numbers. What kind of numbers don't have square root? Real square root.
negative numbers.
That's right.
That's
What
true.
about 0? Does 0 have a square root? What times itself is 0?
0.
0.
0. So 0 does have a square root, but any negative number doesn't. So to find the domain of something like this, we're going to take whatever is under the square root symbol and set it greater than or equal to 0. And then we're going to solve for x. Well, help me out.
Okay, so we need to separate x from everything. So move the 2 to the other side. So that would subtract 2.
Very good. That gives us 3x is greater than -2.
And then divide by 3.
Very good. So now we've got that x is greater than or equal to -2/3. So help me out here. Is -2/3 the lowest value or the highest value?
Lowest.
Lowest value.
That's right.
It is the lowest.
That's right. Because the opening is next to the x. X is bigger than any of those. And if we put in an x bigger than -2/3, is y going to get bigger?
Sorry, you said if we plug in something for x bigger than 2/3, is y going to get bigger?
Yeah, or smaller. So if we
Big,
plug in a
right?
bigger X, is the output gonna be bigger? Or if we plug in a bigger X, is the output gonna be smaller?
So let's say if we
Uh,
plug in for 1, right? If we plug in 1, see 5, square root of 5.
It's gonna get bigger,
It's
right?
bigger, I think.
yeah, it's gonna get bigger because, I mean, practically the lowest you can go is 0, so
Exactly
anything
right.
higher than that will be bigger.
So exactly right. So here we've got the domain of F. Let's write this in interval notation. Do we actually get to include negative 2/3?
Yeah, so it should
Yes.
be a bracket, right?
That's right. And what is our upper limit?
Infinity.
Infinity.
Very good. And why do we always put a parenthesis next to infinity?
Because it's increasing without bound.
Right. And because infinity isn't a number, it's a concept. Any number that you throw out, somebody can give you one bigger. Okay. When we put in, let's just look at something. F of negative 2/3. So we're going to plug in this lowest value. That gives us 2 plus 3 times negative 2/3. What's a nice way to multiply 3 and negative 2/3?
You turn 3 into 3 over 3.
3 over,
3 over,
Sorry.
Yeah, 3 over
yes.
1.
Okay,
And then
and so then we've 2 plus, well, it's still minus. But now what do we have?
It should be -2 because the 3 should cancel. Or
That's right.
yes, okay.
Yes, you could do it that way, or you could you do 2 minus,
Yeah.
3 times 2 is 6, and we leave the 3 because 3 times 1 is 3, and then 6 over 3 is just 2. So same answer, and then 2 minus 2,
0.
0.
and square root of 0.
0.
And that means that the range is going to start at 0 and go to infinity. And I'm going to change the share just a second. Okay, I really want you to use Desmos. Desmos, the address is desmos.com/calculator. There's another Desmos tool that we're going to use a lot as well, but this one we're going to use more than anything else. I want you to use this because it can give you a hint or an idea of how changing a little bit of a function changes its look. So like we had f of x equals, let's see, I think there's a square root thingy. Square root of 2 plus 3x. Oh, I see why we're not. Oh, because I didn't put equals. Okay. So let me change there's a little wrench. Do you see this wrench here? If I tap on that, I can change the step and also the range. So let's see. Okay. So now it's really easy to see that f of x equals the square root of 2 plus 3x is definitely going to be a function. And I know that 0.66666 is 2/3, and this is negative, so negative 2/3. Let's see what happens if we have, let's see, square root 2 minus 3x. That's kind of interesting. And what if we switch the order? What if we had h of x is the square root, come on, of 3x minus 2? So it's really easy to play with a function, change things a little bit, and see what those changes do to the shape. And for that reason, I really encourage you to use this site. You will be able to use it for almost all of the exams, I think. And since we're here, all of our exams will be paper and pencil. So I have them written. We'll have a review sheet. Everybody will do the review and all that stuff. And then you'll get your copy of the exam, and you can print it out or use a tablet or whatever. But you'll work on paper, take photos of it, and send it in. Because then you get used to doing so many important things. You get used to being careful with your writing. You get used to communicating with mathematics, because that's people always say, show your work, show your work. But what they really mean is communicate. Communicate what you're doing so that someone else who doesn't know you can pick it up and go, oh, now I see. So communicate. And it just helps you develop it in all kinds of beautiful ways. So do y'all mind if we take a short break? I'm so sorry.
Sure, that's fine.
Yeah, that's okay. That's okay.
Okay, well, I'm going to stop the recording and actually, yes, I'm going to stop the recording. So who's going to remind me to